Hi all, this is Sandhya, Associate Professor in AC Department from VVC Engineering College, Oral Revu, Autonomous. Today I'll discuss about double-ended clipper. Before going to start about the double-ended clipper, first we'll discuss about what is meant by a clipper. Clipper is a circuit which is going to clip off some portion of the input signal, either clip off or cut off some portion of the input signal. That portion will be in the positive or in the negative, or the combination of both positive and negative. Here the double-ended clipper means that the clipping part will be in the positive portion as well as in the negative portion. Any clipper can be implemented by using diode and resistor. As we know what is the use of the resistor, it resists the flow of current. And now coming to the operation of a diode. Diode is a two-terminal device which is having the two terminals of anode and cathode. Here the two terminals are, one is the anode and the second one is the cathode. It is operating in the two biases such that one is forward bias and the second one is reverse bias. What is forward bias and what is reverse bias? In the forward bias, the diode is in forward bias if and only if more voltage is connected to anode terminal and the less voltage is connected to cathode terminal, then the diode is operating in the forward bias. In similar way, the less voltage is connected to anode terminal and more voltage is connected to cathode terminal, then the diode is operating in reverse bias such that it is in off condition, open circuit. Whereas if the diode is operating in forward bias, the diode is in on condition and it is acting as a short circuit. Now the double-ended clipper, it uses the two diodes of D1 and D2 with the two reference voltages of VR1 and minus VR1. That means the magnitude of the VR1s are both are same, but the diode which is connected in forward bias is with positive reference voltage, whereas the diode which is connected in reverse bias, it is with the negative reference voltage of minus VR1. Now based on the diode operation, the diode will be either in on or in off based on the voltages applied to anode terminal and here the cathode terminal. As there are two number of diodes are there, we can get four possible conditions for the two diodes. For diode D1, the condition is Vi less than VR1 and Vi greater than VR1. Whereas for diode D2, Vi less than minus VR1 and Vi greater than minus VR1. For the two diodes, the diode condition on and off conditions for the two diodes D1 as well as a D2. Now we are going to minimize these four conditions into three, as here the first condition is same as it is, that is Vi less than minus VR1. Vi less than minus VR1, and the last condition is also as it is, that is Vi greater than VR1. Now I am going to minimize the first and last condition such that in these two conditions, in this case Vi value is more when compared to minus VR1, and in the first case Vi value is less when compared to VR1. So now we can combine these two cases as single case as minus VR1 less than Vi less than VR1. Now we minimize the four number of cases into three number of cases such that in these three cases, what about the operation of the circuit and how the diode D1 behaves, how the D2 diode behaves, and what about the output of the circuit, we'll discuss now. Let us discuss for the first case, that is Vi less than minus VR1. For the first case, that is Vi less than minus VR1. That means minus VR1 value is more when compared to applied input voltage. Here the input voltage is applied here, that is connected through resistor to the diode anode of D1 as well as cathode of D2. Now the diode D2 voltage, cathode voltage is with Vi, anode voltage with minus VR1. Now there is a relation between Vi and minus VR1. Minus VR1 is more when compared to Vi such that more voltage is at cathode anode of the diode D2 and less voltage is at cathode of diode D2. Therefore diode D2 is in on condition. Diode D2 is in on condition. So it is acting as a short circuited diode. Now coming to the D1 diode, here Vi value is less when compared to minus VR1. So Vi value is less And if minus VR1 is more, then plus VR1 is also more, then the diode D1 is in reverse bias such that it is in off condition. So it is acting as open circuit. Now the output voltage is voltage across the short circuited terminal, that is output voltage is nothing but minus VR1. So for the first case of Vi less than minus VR1, D1 is off and D2 is on and the output voltage is minus VR. So D1 is off and D2 is on and the output voltage is minus VR1. Now let us discuss for the second case, that is minus VR1 less than Vi less than VR1. For the second case, that is minus VR1 less than Vi less than VR1. That means what is the meaning of this condition here? Input voltage is in between minus VR1 and VR1. That means input voltage is more when compared to minus VR1 and less when compared to VR1. Now apply this condition on this circuit diagram. So input voltage is more when compared to minus VR1. So more voltage is connected to anode of diode D1. So the diode D1 is in on condition. And coming to the diode D2, minus VR1 is less. So diode D1 is in also in off condition. So both the two diodes are in off condition since both the anodes are connected with less voltages such that output voltage is equal to input voltage. So when the condition of minus VR1 less than Vi less than minus plus VR1, the two diodes are in off since the two diode anode terminals are at less voltage when compared to cathode. So entire circuit is open circuit. The output voltage is equal to input voltage. Now for the third case, that is Vi greater than VR1. For the third case of Vi greater than VR1, that means VR1 value is more when compared to input voltage. So VR1 value is more when compared to input voltage means diode D1 is in on condition since Vi value is more when compared to VR1. The case is input voltage is more when compared to VR1. So diode D1 is in on, so it is acting as short circuit. Now coming to the diode D2 here, VR1 value is less when compared to Vi. So Vi value is more, that more voltage is connected to cathode of diode D2, whereas anode of D2 is connected to negative voltage. Diode D2 is in off condition such that it is acting as open circuit. Now the output voltage is voltage across the short circuit terminal, that is diode D1 is in on, it is short circuit, so the output voltage is nothing but VR1. So it can be as diode D1 is in on and D2 is in off, output voltage is nothing but VR1. The input and out, coming to the input and output waveforms here. So the input waveform is a sinusoidal signal. We took the input voltage as there are two reference voltages are there. So one is the positive reference voltage and the second one is the negative reference voltage. So positive reference voltage plus VR1, which is above the zero reference line, and the negative reference voltage below the zero reference line, that is minus VR1. So the plus VR1 and here it is the minus VR1. Now coming to check for the conditions. The first condition is Vi less than minus VR1. Output voltage is minus VR1. So check the area, in which area minus VR1 is more when compared to input. So in the entire input value, minus VR1 value is more and input value is less. So observe this area here. In this, minus VR1 value is more and input value is less. In such a condition, what is the output? Minus VR1. So in such a condition, the output value is nothing but minus VR1. Minus VR1. And next, a second condition. What is the second condition? Minus VR1 less than Vi less than VR1. That means input voltage is in between minus VR1 and VR1. In that case, output voltage is Vi. So here in the output waveform, input voltage is in between minus VR1 and plus VR1, minus VR1 and plus VR1. In these regions, what is the output? Vi. So the output value is nothing but Vi. Output value is Vi. Now for the third condition, Vi greater than VR1. That means input voltage is more when compared to VR1. In that case, output voltage is VR1. So check the output. Input voltage is more when compared to VR1. So in that case, output voltage is plus VR1. Output voltage is plus VR1. So in such a way, we can get the output value of double-ended clipper by clipping in the positive as well as in the negative portion. Thank you.